G'day guys, been playing around with this new module on the GPX5000 and yeah, had Eugene running around with the detector. Got a lot of feedback, which is great. Thank you, Eugene. Yep, he knows what he's doing. I tell you, he tried it with a numerous amount of coils as well, which is really good. And I have got it in well, not email, but via messenger, so I might click it up and read out the exact findings. But what I've done, because we're going to make this a kit, we're going to supply, especially over into Africa. David has, I don't know why he made them bright orange, but that's the little pot box it goes into. You can see that. It's like, well, basically you put the board in there and you put a sealant over it. So we've got a fair few to make. I've got people wanting them already, so I've got to put them down there. But what I did with the initial findings that Eugene did, he said that there wasn't enough spread range on the pot when you adjusted it. He said it was all happening over half or a quarter of the range, and the rest of it was just basically didn't do anything. Well, it did. The detector worked, but you couldn't peak it over that remaining half turn. So I've rescaled the input stage on this, so it now has a lot more range, and I've got it on this detector at the moment. And the other thing I've done too, I just ate a protein bar and stuck in my throat like usual. Yes, high protein, yeah, well, high energy protein bar. Famous, it'll make you famous. It'll stick in your throat. Anyway, with this gadget here, what I've done, because at first I mounted the little module underneath the board, and I said, oh, you could, I'll get a board here. I was just testing out another conformal coating mover. This one works as well. I'll let it dry out, damn it, but I should have cleaned it right off. But with the boards, I thought, you could get it and you could stick it in around here or whatever, as long as you miss the channel there and the channel there on the case that goes over it. And then I thought to myself, no, that's going to be too hard for people to do. So what I've done is it goes on this side of the board now where there's tons of room. So make it easy. And on here, there's two relatively, well, not relatively, they're large electrolytic capacitors, but there's two electrolytic capacitors here. And I thought the best place to put it, why don't we just put a couple of dabs of hot melt glue on these two, and stick it down. And I did that, and it's not going to come off ever. And if you're worried about temperature and hot melt glue coming off, you could just stick it with, you could bloody use super glue or anything. Even rubber glue or something like that, it's not going to come off. It's not going to. If you want to be really pedantic, stick it on the coprocessor thing here, the thing that does all the audio, and it's not going to interfere. It's not going to have any coupling whatsoever. Or if you want, stick it on these chips here. Just stick it down. Bang, done. So there's no coupling. You're not going to upset anything. I would have, yeah, damn. I'd avoid sticking it on the transformers. Well, that's a transformer, that's an inductor, but I wouldn't stick it there. I would stick it on those, and that's what I've done. And yeah, it sticks like the proverbial to a blanket, and We can tap off, there's a couple of points on here we can tap off. If I do some documentations, I'll tell you how to do it. And very easy to wire it in. The only thing you do have to change is, like I said before, you have to change that, which is pretty straightforward. If you want to get really, if you had a pair of sharp snippers, you could probably just get in there and snip the legs on it, heat up the tab, the whole thing will fall off, and then take off the remainder of the legs, or heat the whole thing up with the hot air tool and just drop the whole thing off the board. And the new one we got that goes there, yeah, just stick it in, solder it in, away you go. It's really pretty simple. I've done a few of them now. Now, because Eugene said the other one didn't have enough range, and because I potted it in epoxy, right? Can't do any adjustments. So I said, well, because I put it in epoxy, let's see if we can back engineer it, see if we can pull it apart. And we tried various chemicals on it. We tried soaking it in acetone, isopropyl alcohol, normal alcohol, Sally's paint stripper, all sorts of stuff, and also some MG chemicals meant to eat anything, but it didn't. So anyway, what we ended up with, if I've still got it and haven't binned it, which I could have, I wonder if I binned it. By the way, the detector's on. It's just running in the background there. You can probably see it's in enhanced mode, sitting on the oscilloscope. That's its waveform there. Oh, here it is. Okay. This is a module that I tried to actually chop into it and get onto the components and things. No way known. This is hard as a brick. And what I started finding, I started chipping away at the edges here, and it just started damaging the internal surface mount components. So I think it's pretty safe. It's along the lines of, you could say it's along the lines of the black modules in 6 and 7. You're not going to get into them. And I think that that's a good way of doing it. When you come up with novel discoveries or inventions, or a very clever way of doing things, hide it, right? Just hide it. Make it nearly impossible to get into to see how it's done. You could go and measure all the output and inputs and see what's going on, but try and emulate it in real life. I bet you can't do it. But anyway, I'll give you an idea. I'm trying to find a pair of pliers or something. I'm going to give it the crush test. Get a pair of pliers and stick it in and see if I can just crack some of this. I was going like crazy on that, and all it does is just put a couple of little teeth marks on the edge. You can't get into it. It's quite amazing. I'll try and chip it with a little bit of a bite. I'm doing this on purpose because a lot of copycats out there. One in particular has said that I've copied their stuff. Oh, actually, no, there's a few. They're all been pump primed to say that I copy their stuff or something or other. I do not copy anyone's stuff. Okay. So I'm just proving how small this is. The way I've done it, it's working there in the detector. I'll show you in a minute. And that no one else has it out there. Okay. I'm just going to show that, you know, I'm not copying. So it just blows their arguments away. Oh, you copied so-and-so's stuff, and whatever, bull dust. Absolute crap. Anyway, I'm trying to break this open. I can't. So anyway, in the bin. Now I have people going through my bin, won't they? You won't get it apart anyway, or smash it to pieces. The way it's built, you'll just destroy it. So you'll never know what it was in the first place. So anyway, what I've done, the module is sitting in there. You cannot see it. This is on. Pick up a screwdriver and just go over the coil. So at the moment, it's sitting there. It definitely is in cancel mode, and I've got it sitting on low gain. So I'll crank the gain up a bit. You probably can't hear that. I might hide that schematic and get rid of those as well. And I'll plug this into a battery and amplifier, except that's right, because the battery I had, Eugene had it out. So yeah, as I say, he had it out with the pack. So rather than that, how about I find the information? I am trying to describe this gadget, but I'll give you some more feedback on it after he tested it with the other coils. He used Nugget Finder coils. He used Coiltech coils. He used, I don't know what other coils he used, but I'll just grab this and we'll go over. Oh, hang on a sec. Running out of floor room again, as we do. I'll put it over here this time. Okay, let me have a look here. I'm going to turn the computer on, and I'll find the information. And I don't want certain things popping up, as you can probably understand. Okay. Messenger. Don't want that, don't want that, don't want that. He might have done on my other account, so I might have to switch to it. Here we go. Okay. There's a message there in Italian. Okay, here we go. I'll have to hide all that. Make sure it didn't. Okay, here we go. From there, we're trying to get out together. We're trying to get out to the local area here, but I just got snowed under and I couldn't go. But anyway, yeah, I don't think there's nothing there you can really see. But anyway, I'll read out his last lot of testing. Okay. Yeah, like I said, work out time, I'll meet you there. And I say, got too much on trying to get on top of stuff. Yeah, okay, this is Eugene. Okay. Yep, I know what it's like. Looks like rain is going to be setting in this afternoon. Got some more testing done this morning, but I think, as you said, the range needs to be reduced slightly, as some people might get mixed up with it going into the drop-off and making the coil deaf. So that's basically, I've given it enough range that you can completely underdamp the coil. And if you underdamp it, what's going to happen is going to saturate the front end. Everything's going to come through, and the poor old front end, the input stage, is going to be saturated, which means it won't be able to move like this. It'll just be banged up hard, and there's no movement there, and you won't be able to hear anything, because you only hear when the signals are moving. Right, so that's the idea. That's as simple as I can put it. But anyway, let's go. Some people might get mixed up. Yeah, drop off, make the call deaf. Apart from that, all is good. Nice and quiet and very responsive on targets when calibration is at its peak performance. I have also tried the new Nugget Finder coil with it, and old coils going back to the Gold Hawk range, the Evo range, the Commander range, Sadie, etc. And they are all within a quarter of a turn to half a turn to the most. So that's what we're saying about the range was too, I made it too broad, right? I'm trying to cover everything you could ever throw at it, but with probably 99% of coils, instead of being over a range like this, they're over a range like that. So what I've done electronically is I've got that range there and I've spread that range over here like this. So it's very more easy to tune. So anyway, heading home now, got the lawns to do and a few other things as well before the rain. Let me know when you are free. We can either do some testing or I can drop the detector backs for adjustments, etc. Cheers, mate. Eugene. And then he said, oops, gold stalker coil. So he's used a gold stalker coil on it too. Yep. So anyway, I've worked on this. I sent him a message. I just finished building the next module with the quarter turn over the whole pot range. So it's got a good range now and there's no dropout. Well, I did leave it a little bit on the far edge, as far as you can turn it as a dropout zone, which basically you know that that's where it is under damped and all the rest is variable damping and time shift. So that's where she goes there. Yeah, so anyway, it just says, yeah, I just said I can knock it over tonight if you're in the area. Yep, home at the moment, yeah, yep. Just got to mow the lawn first, should be good. Nah, then he come around because he decided not to mow the lawn. So his wife will be really upset. Oh, well, there you go. So, as before, let's go down, scroll back. Just as a refresher, it all went good. Had fun working it out. You know, I think I've said this before anyway, but the bit that really gets me is that he was able to use the 14x9, 10x5, Evolution 11, all very good on a 0.04. And that's a very small piece of gold because I'm using a 0.05 as my small target. And he's using one that's 25% smaller. Hang on a sec. I'm going to get out of here and go back to my other workbench. I think I'll go right up in the air here, get over everything and don't step on anything. Okay. I think I'll land that in the same spot, but I'll show you what this, how I've done the module on this anyway. I know there's a lot of guys out there who like knowing all the technical aspects at the expense of people that don't. But can't keep everyone happy, right? You just can't. So anyway, on this one here, you see the module, I've stuck it on those two capacitors. So it's not going to come off. I mean, you know, I can bounce the board up and down on it. So should have a drink. The gummy bar is really stuck in my throat. Okay, now this board here, it has, obviously it's got variable time shift damping. It's got, I don't even know if you can see that, the mylar's in the way, but it's got a buffered variable gain stage. It's got dual channel low noise amplifiers, and these are really, really low noise. These are pushing the limits. What else is on this one? Okay. No, there's a whole heap of little tiny chips in there and stuff in there. Just trying to get rid of some of the capacitance out of the circuit. On these things, capacitance, on signal lines, capacitance is your enemy. You don't want that. And capacitance and resistance is usually your enemy. So, and on there, I've done some other changes there, but you know, nothing fantastic. Like I say, this is my own detector. It is a just basically a tester, sacrificial test detector. It gets all the latest and greatest in it, and yeah, and that's how she looks on the front. I found the Allen screw for that one there, so I'm going to change that. So we'll have standard type pot like that for variable gain. Same sort of pot I'm going to put there, so it's more low profile. It's still easy to operate. They actually, when they manufactured these, they look like there was provision for an extra pot there. I've said that before, but I'll say it again. So you could change all these and match them. You can put different colors in there if you wanted to. But yeah, I think I'll just get rid of that black one because I had to find the little tiny Allen wrench to undo it, and it only just turned up after I had to clean up as usual. So guys, this will have to go out and be tested in the field, this new module, but we can do more tests here and I can show the extended range, but I'm going to have to change this to a different if we ever get that back in there, get in there. Tell you what, there we go, got it. There's some mylar strip going in. I wanted to do this as I was pushing it in. I'll get a battery here. I don't want that. I've already got an amp. Undo, please. Undo. Oh, there we go. Okay. Oh dear. And we want to have the battery go into the amplifier. Click. Speaker comes out of that battery into that amplifier. This one goes in the back of the detector. Now we'll have a bit of noise. I'm trying to keep all this nice and straight so I don't strain any and everything. Put a speaker there, that there, turn some audio on. Okay, and put the coil back in. Okay, I'll give it some volume because we probably need some. There, that's the amp turned flat out. If I get a piece of metal and go over the coil, it will absolutely scream. Okay. Okay. Hear those blippy noises? That's because the mylar strip isn't connecting properly, hanging down and pushing the fingers over, losing tension and dropping the one of the control lines out. I heard it double blip, but that's all right. No settings have changed. Good. Yeah, if you these mylars here, if you bend them over, the hear it blip. I'll do it again. Just listen. Yeah, you got to keep them clean and make sure they don't lose tension. Depends what data line opens and closes. A detector will either have complete hernia, or it'll just just reset back to where it was. It can actually reset all settings back to factory defaults. So yeah, just make sure that they go straight in and not pulled this way or that way. Anyway, let's have a look at this. Well, actually, what I should do, I'll hook up, rather than looking at the transmitter output, how about we go look inside the detector to what's going on. So I'll get onto a good earth here. Actually, I've got some open pins. I want to be careful doing this because I'm actually using the ground there as to tap off onto the module. Gotcha. That'll be good. And I better do that, or else you won't know what's going on. Okay. I don't even know if I'll be able to get close enough on this, but we'll just give it some amplitude. Definitely like that. I say these things hate mixed signals. Okay. I'll give you an idea of all the noise in this joint anyway. I can't zoom this, but maybe you can if you're watching it. You see on the oscilloscope there, I don't know if you can see it very good. Pulse has just occurred. There's a flyback, and this is the receiver on here. And if I'm on 10 millivolts, I'll take it down a bit more. There we go. That's on 5 millivolts per division, vertical. And if you can have a look at it, I'll just turn up the brightness because you can see it with more brightness, but I just don't want to burn out the cathode ray tube. That's full brightness on that, but anyway, there's a heap of noise there. It's got about 10, probably about 20 millivolts of noise running there, and that's our curve sitting right there. Now it's not very steep because I'm not running much amplification. I can crank the amplification up, but as you can see on the waveform there, there's a whole heap of noise up and down. That's probably 50 hertz getting into it. And I know that thing gets into it. The soldering iron next to it has a switch mode type, or either a triac or a switch mode supply, and it causes havoc. So I put the gain up, and you can just see there is just massive amounts of noise. That's just noise in the room. That's just tons and tons of noise. So if we get on the coil here, normally you'd see that a movement there, either at the top and at the bottom, but it's so much noise that you can't see it. That's how sensitive these detectors are. So it's sitting there going to scream like a banshee. Now if I do the variable, yeah, I'm going to take it down to where you won't be able to see it like that either. It's really hard to see. I might have to okay. You see these transitions? I don't know if you can see them. It's a couple of transitions there, and the flyback where it switches. Try the right pot. Now see that? That's under damped. That's getting clobbered. And the slightest touch of the pot, we're back into active territory. So the coil starts working. I see this curve here on this vertical part. As I put more and more damping in, and you can see some other transition happening here. And that's full damping. But I've got a slug of a coil on it, so it's not going to make much difference. It's got that on it. Yeah, I can't pull that down. But yeah, that's what I'm running at the moment. So it's not that much of a finicky coil. But what I did find when I was using the newer coils, it absolutely peaked the sensitivity. But as it peaked the sensitivity, the noise went down. So it's like a mega bonus. I'll just turn that down a bit. That's at 100 millivolts of division, so it's pretty crazy. But if you want to know what we're all talking about, the decay curve, that's it there. This is what everyone says when they're talking about decay curve. They're talking about this line here and how it curves in. Basically, flyback's gone, whack. It's been damped down or clamped down to about 200 volts. And after all the dieback, you'd be getting a curve like that. If you put ground near it, say I put a hot rock near it or something like that, that curve will change. Have a look. See, it's gone higher. Or maybe I'll do that. You can probably see it better. Maybe I even do that and bring that down there. You can probably see that. But if we take, I've got the ring on, damn it. I have to use the other hand. If take this away, you can see that curve. So I'll leave the hot rock there, and I think that's gone into, no, it hasn't. I thought it had gone into under damped. It's still getting pretty close to critically damped. I can't see the top of the curve. Now that should be, like I say, I tried to extend the range but have it over more compressed. And if I get the coil now, okay, that's heaps weaker. That means that we are totally under damped, right? But the decay curve looks perfectly fine, but in reality it's not. So what we'll do, we'll give it a kick of, now here it's made an input transition, and that's why it makes that buzz noise or whatever you want to call it. But now we'll have complete proper damping, near enough. Actually, I think I can do this on the oscilloscope and show you, but I'll have to. Okay. This might, it's done a double time-based lock-up thing, but anyway. I don't know if you can see it there. There is the top of the sample curve. It may be hard. It's right next to that marker. It's right next to it, and it's a little bit under the height of the marker. I don't know. I'll just see if I can talk it through. So we get there. Like I say, it's a pretty crappy old coil. Oh, there we go. Now see how that vertical line's gone flying actually off the screen now. That is critically damped. And it's as sensitive as all hell. And I've still got the hot rock sitting there, so. But yeah, I've got the brightness on this flat out. I can't drive it any harder. I can make the numbers light up, but I can't get the trace. I mean, this thing's absolutely flying. It's very, very fast. It's very hard to sort of, with this stuff here, what we got, the way it's set up to visualize it. I should have brought out the other digital crow. It may make it easier to see and brighter, but it's damn noisy. It's got cooling fans in it that sound like a jet aeroplane going off. So maybe there you go. I've got the time base going properly there. There we go. That's where the marker is there. And if I adjust this, see it's dropped. It was up here. And now I'm over damping the coil, okay? So what you'll need an oscilloscope on your detectors to see where critical damping is. There's probably a way to do it, but you know, you'll know damn well when you get it perfectly right. Like at the moment, that's just spot on, perfect for this coil. You know, I'm way up over the coil, and I've got this thing on fairly low gain at the moment too. So different modes. That's a mess. Okay, that's running in normal timings now. Again, I don't know if you can see on the oscilloscope. Oh, look at that. Up there. There we go. Now, isn't it funny? Using the same coil and just changing the timings, the damping setting needs to be changed again. So that's critical damping for normal. And I think enhance is probably going to make no difference. Where are we? Down there. We go to enhance and we'll just see. Oh no. Well, that's interesting. I'm getting a double response in enhance. Let's see what's going on. That's as sensitive as almighty. Now it's bringing that up, I can see. We go back the other way. We're going to go lighten the damping off. Interesting. It's far more sensitive there. And there's a flyback pulse screaming up there somewhere. And it's interesting. That's why I don't know if it actually, just turn that off. I don't know if it actually needs some sort of indication, because you can just hear it yourself. If you have a small target and you're just going over the coil, just adjust it till you get maximum amplitude, and it'll work perfectly fine. I'll try one of the new monos on it. You see what sort of spread we get between an old dunger like that. I shouldn't really call it a dunger, should I? But okay, this is the Elite Max. Getting crowded in here. Okay, stay there. It's got very springy cable on these, and we want to pull everything off the bench. So what we'll do, we'll fire it up with the Elite Max on it. It's going to be as noisy as hell, but what I can do, I know, just leave it in cancel mode so it can't make any noise. But we'll just have a look at the damping effect on the coil. Obviously, because everything's changed again, we have to rearrange. And I had this in enhance. Now look at this. Now that's where it was with the other coil there. If you can see where it was there, but that was peaked for the other coil is up here. Now it's dropped down there, so it's telling us the coil's different and needs a different damping profile. And look at that, up we go. there you go there. That's moved it at probably about 2 out of 10 on the turns ratio, and it's completely repeaked for a different coil. Let's try that and try a different mode. We'll go into normal mode, and I'll just timer line that up. Now, it's definitely dropped off. Let's see where we go. Don't do that. Oh yeah, miles difference. I have to put some timing delay on this. It doesn't want to behave. So you can see those spikes there. They will indicate critical damping. So we could probably actually sample those and have it drive something. You know, a numerical LCD indicator, or we could, God, you could put a bloody, you know, LED on it or something that gets brighter as you increase the voltage. So that wouldn't be too hard to do. And see, you can just muck around everything here. Okay, that's getting towards critical damping about there. See, that's a right near the end of the range. That's why I didn't want to go too far. So that's critical damping there. Now, the thing is, because I've got it sitting there in cancel mode with a mono on it, it's going to be quiet. It's going to be dead. But if I flick it into mono, it's going to go completely nuts and get deafening. But we'll do that just for the fun of it. Okay, there we're in normal mode. Yeah, I'll turn the gain down to basically nothing. So it's still just massively sensitive. It'll pick up everything in the whole place. I can see that line there. There we go. Okay, I can just see small line there, which is basically critically damped. So got no gain, but it's just a lot of bucket of noise. Yeah, it's just too much electrical noise. Like I say, trying to run a mono inside a workshop is a fool's errand. And there it is. That'll prove that. So we can fully overdamp that coil. Still going to let the noise in if someone wants me. And have a look at this. I'll see if I can do a bit of a show and tell from critical damping to overdamped. Okay. See, much more sensitive when you get the damping correct than flat out. So that's the name of the game. You can now optimize these older detectors to any core you want to throw at it. You can use some big, horrible, massive, high capacitance, higher inductance coil. You'll be able to probably damp it. Because they are really, really fussy for the overall peak sensitivity. You just can't shove everything on it and say, she'll be right, mate. No, it doesn't work that way. It has to be specifically damped for the type of coil, because all the parameters in the coil will change. You know, it might have different resistance, it might have different capacitance. you know, wound differently. It's going to have something different, you know, in the way the reactance of the coil, the way it's showing it to the detector input circuit, because it wants to try and smooth it all out. I mean, on a big coil, you can turn the damping right down. You can actually, it just starts letting all the, you can see the coil ring actually, basically. The coil turns off and the damping circuits, if you don't damp a coil, it just rings like this. It's just like an oscillation, like a sine wave, but it goes down in amplitude over a period of time. And what happens, you've still got it doing this, and your receiver comes on here, it's going to get this loop through it and stuff everything up. It's not going to work very well. It's going to really impair the performance. So that's why you want to dampen this oscillation out and stop it as quick as you can so you can sample early, but you don't want to squash it so badly that it starts affecting the decay curve and start squashing that, because then you're going to start losing target signals. So that's why it has to be adjustable. It can't be a fixture. So yeah, the next models we'll see will have variable damping on them, unless they already have. But it might be done, as I say, you can measure it, and you got to be careful too. If measuring coil damping and trying to do it electronically, and adjust some sort of network to compensate. What would happen if it's if you're near power lines, right? And you got this, and it says, "Oh, I'm going to compensate for that," and it's doing the damping, right? It's actually compensated for the power line noise, and your detector goes as deaf as hell. Or the worst thing, it goes as noisy as hell. It doesn't know any different. But that's the nature of the beast. That's what we're going to deal with. So I have a read up on critical damping. If you wanted to do this, you could probably, there are other ways of doing this, right? But it needs, don't try and do it with potentiometers, right? I mean, don't do it with a potentiometer connected up onto the damping circuit. It's just going to get 200 volts up its jumper and it's going to go bang and blow up, okay? It's not going to, no pot will handle it. It won't handle the current. I think the average current's somewhere between 500 and 700 milliamps, but start adding that up to you know, 185 volts and multiply it out. That's your wattage, your peak wattage anyway. It'll blow most things to bits. If you ever touch the damping resistor in the detectors, you can burn your finger on it because it gets damn hot. It's dissipating all that energy, or a lot of the energy from the flyback. So if you wanted to do it, you could put a multi-turn, like a switch thing, like a Lowland switch, you know, 6 position or 8 position, and you need non-inductive metal film 2-watt resistors, and you could solder them all in different values, but you're probably not going to nail it, because if you see, even on that, slight resistance variations, which I'm doing in the control circuit, is critically damped or not. So could you do it with a whole heap of resistors? I don't think you'd nail it. You'd get different coils and it won't be right. So I think the way I've done it's the best. As far as I know, no one's done it. I haven't seen it anywhere, and I've been around. So yeah, because I think in the early days we did try and do it with pots, and we put paddle resistors on the pot terminals to keep the wattage up, but try and keep part of the range, and just having all those wires and things to the pot and the metal body of the pot and everything, just basically made it go pear-shaped. It didn't work. So the way I've done it here seems to work really well. And if Eugene, who's out been, you know, he's been out testing, can use those bigger coils and get 0.04 gram bits of gold, I'm not going to argue. I'm going to accept that because, yeah, he's had a lot of experience with detectors, all sorts of detectors and all sorts of coils, and been doing it for years. So that's that. I hope that is of interest. So like I keep saying, these old detectors, right, don't get rid of them, keep them. They could be made really, really good. This thing here, it's probably what I would call my go-to detector. The way it's behaving now, it's bloody fantastic. You know, it really is. It's really, really good. I could, no, not going to. I could, I could fire up 6000 and do a comparison side by side with the same sort of coils. But yeah, because I've got a, oh, could I? You know, I could do that. I could just do it here in the lab, put it on the hot ground and throw all sorts of targets at it and just show you that this thing here screams like a Banshee on very small gold, even just with a normal double D on it. The only thing is the double D, sorry, the anti-interference coil I've got for the 6000, we'll call it a double D. Yeah, it's a 14 and I've only got, have I got one? No, they're all 11s. The double Ds are 11, so there's a little bit of a difference there. But, you know, because the windings just run right next door to each other in the double D configuration, it probably make no damn difference on small close targets. Far field, yes. Near field, no. There'd be no benefit in either coil on near field targets, only on far field because the bigger spread of winding to go further out. So yes, I could do it. I'm not going to do it now and make this a ridiculously long video, but I might do that because I have run the 6000 in here with that coil on it, and yeah, it's a bit noisy, but it is usable, and you could do side by side tests even better. We could probably just do it out in the field, bury some targets and just go over them and see what gets what. Might be the better way of doing it. It's just a lot of setup time, and I lose a lot of time doing that. Like if I go out in the bush, I lose a whole day. I could have been working on some of the jobs here that need to get out the door. Being Sunday, I thought I'd just take a break from doing the work. I've been working on that. Now I've got that nailed, and we could now just I've got a whole heap of other things I've got to do. I've got people waiting on these modules as well. So yeah, I hope you like that. I've got to get making more of these little boards up. I've got a bag of them there, so I'll have to do it, or I'll see if I get Chari to do it. She can solder really well. I mean, what a bonus that is. Most people can't. They look like they're using an arc welder on a circuit board. But yeah, she does really good soldering. So yeah, just natural. But all good. I think that's enough. If you want to know anything specific, just leave it in the comments. I do read them when I get round to it, but you know, this will be up, and I'll probably read some comments later tonight. And but I've got to get some work done, so I better go and do it, or else I'll have people chewing David's ear off. Right? That's worse than them chewing my ear off, because they chew David's ear off, and David comes back and chews me off with all of them chewing him, and it's a pretty decent barrage of how come you haven't done that? Why isn't that finished? Yeah, right. Sometimes you forget who's running this business. Anyway, I wish I could retire. Okay, all good catches.